All right, good afternoon, everybody. So today we are going to be discussing ER modeling. Oh, by the way, this is April 5th, 2023. We are going to begin our discussion on ER modeling today, but this will not end our discussion today on ER modeling, but after I do the quote of the day, there are a couple of other things that I wanted to point out to you and just talk about, not related to this lecture, but to the course in general. So a couple of things. One, quote of the day comes from James Bauer, who says, "I believe the best test of a model is how well can the modeler answer the questions, what do you know now that you did not know before, and how can you find out if it is true?" I can probably give you a ton of modeling quotes. Modeling is my research area, one of my research areas, and so I really love how models can help us describe systems, can help us to describe lots of things, can describe software development processes. In what we'll talk about in ER modeling is how it can describe a database system, and especially how useful it can be to both the technical minded people, the programmers, the developers, the administrators, but also can be useful to our users, to the people who don't have as much technical expertise. And, you know, I mean, we don't need and we don't want our users to have to learn programming in order to interact with our systems, right? All right, so let's also talk about, where is it? Here we go. So I posted this form, I posted this poll or whatever, yeah, I guess it's a poll, for you guys to fill out. I did post this, right? Yeah, I've got some responses already, good. If you haven't filled this out, please do so. We will, I can't promise that the results of this will be used exactly. We do need to figure out what things look like going forward if we do go back to face-to-face. As of right now, the results I'm getting are basically, okay, looks like about a little over half of you have chosen the prefer. Oh, by the way, I do want to point out, if you select this option, the no, I am not able to attend in-person lectures, and if we end up going to in-person to face-to-face lectures, you may be needed, it may be required for you to provide the reason for why you are not able to attend. Okay, so such as if you are not in Antalya for a reason that prevents you from being able to come here, or something along those lines. We may end up needing you to provide that reason and provide evidence of that reason in order to excuse you from any in-person things that would be going on, which would include towards the end of the semester the group project presentation that you would need to give. Also, there is a final assignment that I will give to all of the students during the presentation time, where you will need to show that you listened well to the presentations that were given. Okay, so, and those are both going to be in person if we have in-person classes at that time. Preferring to watch the video lectures on, by the way, again, if we go to in-person lectures, then there won't be updated videos available. You'll have to watch previous semester's videos, which I will provide. I will provide a link to a previous semester's video lectures on my YouTube channel that you could watch them there. But you could do that as well. So yeah, please fill this out. Let me know what it is that your options are here, what you would like to see. Let's see. A couple of you selected other. I will need to look through what those Okay, so one of you gave that you are not available and you gave the reason why. Okay, so anyway, okay. So again, for a course like this where attendance is not required, nor is it a portion of the grade, obviously how we do this is not as important for the grading purposes, but it still is important for us to know what you guys are able to do for us going forward. Okay, all right. So like I said, we'll hopefully have that figured out soon and have an announcement related to what we'll be doing for lectures going forward. All right. Anything else? Quiz results were returned as far as I can tell. So one thing I do want to point out is that if you have any questions regarding the quiz grading or the assignment grading, I need you to contact Doruk Hoja, okay? Because he is the one who is grading the quizzes and the assignments. I will be doing the exams and the presentation, the project and presentation, but he will be handling the quizzes and the assignments. So please contact him if you have any questions regarding your quiz or assignment grade. Okay, all right, thank you. Let's move on. Here we go. All right, so we're going to talk about basic concepts of ER, entity relationship modeling. One of the things is that if you remember UML, if you have a good remembering of UML and you liked UML, this will be fun for you. If you don't remember much about UML that we discussed in 102, or you really didn't like UML very much, well, sorry, but we got to do it again. All right, so we're going to talk about how we can identify and resolve some problems with different UML models to resolve that may creep into our design, right? And we're going to talk about how to build an ER model from a requirements document or requirement specification. All right, so let's look at an example UML diagram. Okay, now if you see this, you might take one look at this and say, okay, I have no clue how to read this, right? And that's okay, right? That's okay if right now this looks very confusing and it looks very complex and complicated, right? I can guarantee you that by the end of this lecture series, you'll have a better understanding of what some of these different symbols and some of these connections and relationships mean, and how to understand how these might become tables in our database system. Okay. All right. Now, some of the different parts of the ER model, we will have entities. We will have relationships between those entities. We will have attributes in the entities. The entities will have attributes. And not only the entities will have attributes, but we're also going to see that sometimes relationships can have attributes too. Usually if a relationship has an attribute, it's a particular type of relationship. We'll talk about what that is during the course of this lecture, but we'll get there. So, all right, let's see, an entity occurrence. Let's talk about some examples. So an entity type is basically an entity. All right, it's tempting. It's tempting to say that an entity will become a table, and in most situations that is true. Most situations, if we have an entity in our diagram, it will become a table in our database. That is not always the case. Sometimes one entity might represent a part of a table in a sense, where maybe two entities together could become a table, or one entity could represent multiple tables. Okay. But usually, most of the time, one entity becomes a table. Let's talk about some examples, different entity types. An entity might represent a physical thing in the real world, a staff person, okay, where we are maintaining information about our staff, or a property, or a customer, or a product, right? There are some examples where we might have an entity that represents some conceptual, some non-physical existence. For example, a viewing, when you view a property, or a sale, when you buy something. So for example, if you were to go on to Hepsi Burda or Yemek Sepeti, or what's another one, Getir, or something like that, and you were to order something, right? Now, the food that comes or the product that comes is a physical thing, but you buying it, you giving money for it, is more of a conceptual thing, right? Because you might not actually, there's nothing really physical. Maybe the receipt is the physical thing, right? But there is a physical part of it. But the idea of buying something is a conceptual thing. But we will still keep track of that. I can guarantee you that in the Hepsi Burda and Yemek Sepeti and websites like that, that when you buy something, they keep track of that information in their database. Right? For example, if I were to go onto Yemek Sepeti right now and pull up, their user interface on their website, one of the things that would come up would be my recent orders, right? And it would give me the option to reorder the same thing again, right? And because they store that information in a database. All right. So these are some examples of things we would want to represent using an entity. Again, a noun that has attributes. So a staff, for example, they have attributes like a name, an email address, a phone number, things like that. Property has an address, a number of rooms, a rent value, things like that. So anytime that a noun in a system definition, anytime that a noun has attributes of itself, like attributes itself as part of it, we will make that into an entity usually. Okay. So the way that we'll draw an entity, right, should be very familiar, right? Here we have a staff entity. It's just a box, right? A rectangle with the entity name inside of it. It'll get a little bit more complicated in a moment because we will talk about what do we do with attributes. So just like in UML, where you took the, what do they call them? Attributes is one name, but we also call them, what was it we called them in Java? I can't remember. It wasn't parameters. Properties, maybe properties. Right, but those things that became the class variables. All right, we had a separate section for that. We'll have that here too, but for now, a very simple ER diagram would just have the rectangle with the entity name inside of it. So relationships represent how two different entities relate to each other. So, for example, we might have, if our set of branches are here, we have a set of branches in our branch entity, we have a set of staff people in our staff entity, we can say that branch has staff people. We could also say that staff work at a branch, right? Either way will work. We can say that either way. But this is the same as the association or the composition relationship, the aggregation or the composition relationship from UML, where we're saying a staff person can work at a branch. Now notice there is a rule that we look at and we see in this particular relationship where one branch can have many staff, but a staff person can only work at one branch. So if we look at it the way now, if we go back and look at our entities, that's represented using a box, a rectangle. This isn't a rectangle, right? This is what's called the semantic net. So this is like describing visually how sets in our different entities might relate to individual members of sets of another entity. But this would be very confusing if we tried to do this on a large system, right? So what we'll do instead is we'll draw it like this, okay, where we will say that a branch has staff with where the relationship has a name. Now, if you remember, from UML, this we refer to as has a relationship. Right. There was another one, and we'll get to it. The other type of UML relationship, right? That was the is a relationship. And we have that here, and we'll get to that later. But for now, we're just going to introduce and talk about this has a relationship. All right. So talk about some of the different relationship types. Okay. Now, the degree of a relationship is going to tell us how many entities are participating in the relationship. We didn't really talk about this much in UML, mostly because most of our relationships are going to be binary. Most of our relationships are going to be one entity is related to one other entity. Now, there can be circumstances where multiple entities can be involved in a relationship. So, for example, a 4-entity relationship where a solicitor arranges a bid on behalf of a buyer supported by a financial institution. That's a lot, right? That's a lot going on. But what it's telling us is that this is a specific conceptual thing that happens, is a bid. A bid happens, right? And the buyer is the one who wants to place the bid, and they want to get the loan from a particular financial institution, and somebody's going to arrange it on their behalf. A solicitor will arrange it on their behalf. And it's a complex financial thing that I don't know. I've probably never been involved in something. That's probably one of those things where you buy something really expensive, like a house or something, that I don't have much experience with. Right? But the idea is that this particular bid, right, must have a financial institution involved with it, must have a buyer that is the one that placed it, right? A solicitor arranged it. Now, could a buyer try to bid on a property or whatever it is with a different solicitor but the same financial institution? Right, yeah. Right. So this is the arranges represents that a particular event happens that involves a particular buyer, a particular bid, supported by a particular financial institution, supported by arranged by a solicitor. Okay. Now, this is probably quite rare, I would imagine. All right, I've not seen many. The majority of what I've seen is two entity relationships, what we call binary relationships. All right, where, for example, here a private owner owns a property for rent. A property is owned by a particular owner. Okay. And then there is also the option, the possibility of a ternary relationship. All right, where you have a 3 entity relationship. A staff registers a client at a branch. So the client becomes associated with the branch. The staff is the one who registered them there. All right, so there's a relationship with these three. There's also, we can have a recursive relationship, right, where the same entity participates more than once in different roles. So for example, if we have a staff person who supervises another staff person. So the supervisor supervises the supervisee, the person being supervised. So this would be similar to what we have here at our university, or multiple companies that you might have worked for as an intern, or have are going to work for one day. With the idea being that we have one table that includes our staff people. So we have, so myself, Nelly Hoja, the dean, the rector, we're all in the same table in the database because we are all employees of the university. But if I am being supervised by Nelly Hoja, right? And so we exist in the same table, but to show that I am supervised by him, we don't have to create another table that includes all the supervisors, right? We can use the same table with this recursive relationship. Okay. You could also have two different entities that would have two different relationships with each other. So for example, here we have a staff person, a staff entity and a branch entity. And we could show which staff works at which branch through the has relationship. So this one represents it's hard to write with this. Okay. Workers, right? So workers who work at this branch. All right. This relationship represents a single person that is the manager, the mudur. All right, and how many mudur are there? Just one, right? So this is a relationship that shows who is all working at the branch. This relationship is telling me which specific staff person is the manager for this branch. Okay. Some attributes. Okay. So let's talk a little bit about attributes. I think we may be able to take a break after this. All right. So some attributes, right, is the property of an entity or a relationship type. So like I said in the introduction, attributes can be on a relationship as well. Okay, it doesn't have to just be on the entities. Okay. We can have a defined domain. What are some of the allowable values for one or more attributes? We'll talk about we'll mention two different types of attributes, simple and composite. Right? A simple attribute is composed of a single component independent. All right, so it would be like I was going to say your birth date, but even that can be component. Let's see. A simple attribute could be your first name. Okay. Your first name is a single component. Now, when it says a simple attribute, we don't mean like, oh, your name is made up of multiple letters, like each letter is its own. No, that's not. Your name, it would be a single value. Okay, a single simple component. Right? A composite attribute is an attribute that's made up of multiple components together that each on their own represent something. So for an example, your address, right? So your address is composed of your mahale, your building name, your street that it's on, the number on that street, so the building number, possibly the floor number that your apartment is on, the daire number, the apartment number itself, the city, or not the city, because city would be Antalya. So what would be Moret Pasha? The ilçe. What would that be in English? I can't really think of what to call that in English. The ilçe. Anyway, but that part, like Moret Pasha or Konyaaltı or something like that. Then you would have the city, the country, the zip code. All of those are different parts of your address that go together to make your address. Right? Now, could we store a district? Maybe so, maybe so. Could we store your address, the entire thing, as a single long string? Of course, absolutely. Right? But you can tell that some systems don't do that because there will be times where you'll be trying to order something, ship something, like through ordering it from like a website. Or one thing that I'll often bring up here is the Ecomet application through the Goç İdaresi, which is actually just across the street from the university. All right, and because their system, when I go to apply for an application, it makes me select first the city, Antalya. Then it says, okay, select the ilçe, the region, the district, what is Pasha. Then it makes me select the mahalle, and it lists. And as I select them, the next drop down only shows me the list of things that are in that region, right? So when I select Antalya, it only shows me the ilçes, the regions in Antalya that are options. Then I select one of those. Then it only shows me the mahalles that are in that region. Then when I select the mahalle, it only shows me the streets that are in that mahalle, right? And so clearly they store the address that I put into the system as a set of multiple attributes that go together to form a composite attribute, my address. Okay, so that would be how a composite attribute could be. All right. We also can have things like a single valued attribute, which means that an attribute that has a single value for each occurrence. So person, user, customer, things like this that may have a name. So when you go to log into your OBS site, your OBS account, or you try to sign into your Microsoft Teams account or whatever, right? A single valued attribute like your name. For every you there, for every time, for the row that is you, your name has only one value. I guess unless you have a nickname, but we'll get to that. Right? But you have one value. Your surname, one value. Probably your email address, one value, and so forth. Okay. A multi-valued attribute. Now notice this is different from the simple attribute versus the composite attribute. The simple attribute is an attribute that by itself is just a value. Okay. The composite attribute is it's made up of different parts to put together to make a value. A multi-valued attribute, as opposed to a single valued attribute, is one that where we can have multiple values for it. So, for example, you go to log in to a shopping website, and they allow you to have multiple telephone numbers. Okay. Now, those multiple telephone numbers don't get put together to make your telephone number, right? It's just that those different telephone numbers are different ways that we can contact you, right? So they may allow you to have more than one telephone number, right? And so that would be an attribute that has multiple values, right? You could have multiple telephone numbers. A couple of final notes that then we'll get into keys. I want to finish the discussion on attributes before we take our break. A derived attribute is something that represents, it means a value that we get from a different set of attributes, different related attribute or set of attributes. Okay. Derivable, meaning it can be calculated, it can be found. Okay. So for example, the one that I will constantly come back to, I will come back to this quite frequently, of a derived attribute. Okay, so go ahead and just kind of like remember this one, okay, is your age. Okay, your age is actually, it's derived from other information. Okay, what is that other information? What information do I use to determine your age? What information do I use to determine my age? Okay, birth date, right? Anything else? You guys said birth date, but is there anything else I need to know? It's not as obvious, but there is another piece of information I need to know. Yeah, today's date, right? Yeah, because if I don't know what today's date is, I can't figure out your age based upon your birth date, right? So exactly, so if I have your birth date, and if I know what today is, then I can get your age, right? Which can be confusing in Turkish, like my son, he constantly tells people that he is 8 in English, but he's 9 in Turkish. All right, so most of you probably understand why that is, right? Of course, I have a theory that if you're young, you always want to be older than you are, and if you are old, you always want to be younger than you are, right? So, you know, so my son, he's 8, but oh, he wants so bad to say he's 9. Me, who is much older than that, I would love to say I'm much younger than I actually am. All right, so, but that is considered a derived attribute. And one of the things that we'll talk about when we start talking about database design, the conceptual, logical, and physical design, those phases. When we start talking about this, we'll talk about how to represent a derived attribute in a database system, because there's not just one way that we have to use to derive that. Same thing with some of these other things, like how do we do a multi-value attribute? How do we do a composite attribute? We'll talk about how to represent that in a system. Okay, a couple of more things about attributes before we get to our break. Right? These terms should be familiar to you. Right? A candidate key, a primary key, and a composite key. So the candidate key, remember, is something that is some minimal set of attributes that uniquely identifies each row. So every row in our table can be uniquely identified by this set of attributes, this set of columns, and no subset of those columns uniquely identifies each row. Okay. Now a candidate key is not automatically a primary key. right? A candidate key is something that could become a primary key. Right, we talked, I've said before, we have an election here in this country coming up in a little over a month, right? All of our candidates, all of the candidates are wanting to win the election, but only one of them can, right? And so the primary key is the candidate that kind of wins the election. It's the one that we chose, and hopefully we choose well. Hopefully we choose the best primary key, right? The best candidate to become the primary key, right? But it is simply the only difference between a primary key and a candidate key is that the primary was the one that was selected. Okay? It is going to be the thing that we use for foreign key relationships with other tables when we get into talking about those. Okay. And then finally, a composite key would be any candidate key that consists of two or more attributes. So there can be a candidate key that consists of more than one attribute. Now, what we'll find as we start talking about how to decide on a candidate key, how do we decide what set of columns uniquely identifies a row and that kind of stuff, is you might find that the data that you have, the data that you already have, makes it quite difficult to define a candidate or a primary key. So for example, if I were to take your information, not your information regarding the university, just your information of who you are, okay? Not your information as a Turkish citizen or as a citizen of whatever country you or I happen to be a part of, but just who you are. Stuff like, what is your first name? What is your last name? What is your birthday? What is your birthplace? Something they ask on Turkish application forms. What is your father's name? What is your mother's name? What else? What is your blood type? There's lots of things, right? We can ask other things that identify you, right? So, question. If I were to give all of that information, like, would your name, your first name, uniquely identify you? If I were to say Joseph, I know exactly who that is because I know the first name of this person. Does Joseph uniquely identify me? In the world? No, right? There's lots of Josephs. In fact, the President of America is a Joseph, right? Okay, so what if I said, okay, what about my first name and my last name together? Yeah, closer, but still no, right? If I add my birth date, maybe, most likely, but still no guarantee, right? I can keep adding information upon information, right? Data item upon data item, right? Column upon column, and I probably will get many columns before I finally get something that will uniquely identify me. So if we have this situation where we have too many columns that are necessary to uniquely identify someone, what can we do? Should we use all of those columns as the primary key, and then therefore it becomes the foreign key to other tables? Right, Arjun, exactly. So this is why, if you look on your university ID, there's an ID number. This ID number is pointless, meaningless anywhere else outside of this university, right? The same is true if you look on your Turkish citizenship ID card, right? Or in my case, my ikamet. If I look at my ikamet number, or if you have a passport, your passport number. These are all things. This is a column that was added to the table to make it something that could uniquely identify you. And we can say one column, right? One column can uniquely identify every person that we store in our system. So in our university database, the student table has a student ID column. Every row in there uniquely identifies which student we're talking about. And the ID is what we use to identify them. Okay. We'll also mention, I don't think it's in this lecture set. I think it's in the future when we get to the design phases. I'll talk about why those IDs are numeric. Usually, not always, but usually those IDs are numeric, and there's a reason for that. Okay. All right. So we'll finish up there for our first hour here. Does anyone have any questions before we move on after the break? Questions or comments? All right, so if you have any questions or comments, you can message me during the break. I'll be here, but for now, go do whatever it is you do during break time, and I'll see you guys. We'll come back at 2:27-ish, a little bit before 2:30, and we'll have, a little bit before 2:30, and then we'll have another discussion on ER modeling. All right.